All right, welcome everybody to the June 30th distribution demo. Today, we're going to go over some of the things that we've kind of talked about in the past, but a lot of things have gotten out of the way and we can start actually doing them now. So, I want to talk about actually how to implement streamlining and reduction of container sizes for the CNG. This has been a personal OKR for mine for a couple of quarters, and I it's always bugged me that we have a bunch of technical debt that results in a bunch of wasted resources, whether it's for us or for our customer. We've talked about this before. If we go back to November of last year, it's been a little while. I went into the details of the impact on capex and opex, and the fact that this technical debt is having such an impact down the line. So now we've gotten a bunch of groundwork done, right? So in order to really understand where things are and where the optimization problems were, we did some digging. The first of that was actually recognizing that we had too many things that depended on Git base because we had too many things that needed Git per se, except they didn't actually need Git. So thanks to Patrick from Gitaly, we were able to drop the dependency on the Git base image where we actually compiled and installed Git ourselves. From there, we were able to merge that with Gitaly itself, and we no longer have Git in the containers that don't actually need it. The next thing along that line was the creation of the GitLab base image. GitLab base image, effectively what this work does is create a image for all the final runtime containers so that you've got one consistent layer that has the base requirements that all the containers are going to end up needing. This is our Debian base. It's got tail, xtail, all the basic, we're going to use this in every container state, just so that we have one shared point in time where we're not running apt-get update every single pipeline to get packages that are identically the same, right? With that now in place, we could actually centralize the set config pattern, which is what we use for templating our configuration files into the right place, right? Whether they're ERB templates or Gauntlet templates, which we implemented as well. That behavior was inside of the Ruby container. So every runtime container actually was based on the Ruby container just so that we could have ERB for templating our configuration files. While that was effective because we could very quickly get everything done, there's a number of containers that absolutely do not need all of the Ruby runtime. The container registry as an example. I mean, we refactored that thing entirely a little while back from the way it was before, and there's absolutely no need to have Ruby in there because it's a Go binary, primarily self-contained, no less, right? So once we had the GitLab base and we could re-centralize the set config patterns on top of the work that we did to actually implement Gauntlet, right? So now we have the ability to have a smaller single binary templating option so that all we have to do is change how our configs are rendered as we put them into the container. And now we no longer need the 230 plus megs of Ruby in every container. That's a significant change, right? Now, obviously, we had to change things around. So in order to have Gauntlet function, all of our configuration templates had to be transitioned from ERB to Gauntlet for those containers that don't actually need Ruby as a runtime. We're not going to have ERB. We first have to put Gauntlet in place, and then we have to configure their templates to generate Gauntlet. Only once that's in place can we actually take Ruby out, obviously. Because we're going to have one of those, whoops, we broke something scenarios, and we don't really want to have that. So now that we have that slew of things in place, right, we have a base image that everything comes off of. We have Gauntlet in place for those things that don't need Ruby anymore. Well, now we can look at first off, taking out Ruby for those containers that don't need it. And two, we can actually, while we're doing this, investigate the size of various layers and maybe things that we did that resulted in something being overly sized, right? Say we do it shown recursively, accidentally creating a giant layer. Why does that happen? We'll go over that in a second. So I have a couple of tools we're going to use today, which are obviously Docker. Particularly going to be using Docker Inspect. Okay. Dive for analyzing those Docker containers and looking at the layers and the impacts of what we're doing. And then we have Scopio for looking at an easy way to look at the difference in compressed and stored sizes, right? So Docker, when you ask it your size, it will tell you the size of the fully uncompressed image in your file system. When you ask Scopio, it will tell you the size of the tarball that is in the remote storage. So that is a distinct view on how these images work out. From that, we're going to use a combination of JQ, YQ, and DU to find out where things are getting too large, why they're so large, and things like that. Okay? So I'm going to start with looking at the GitLab shell container. Hit share screen. Grab you out of the way. All right. That is the other window I'm prepping. So if I have my MR, which is here, the intent of this MR is to remove Ruby as its base image and take out any excess size that I could find while I'm here. There's a couple of changes that result in that. First off, I actually realized that when I tried to change it from Ruby to GitLab base, the in repository configuration file was an ERB, not an output file. So that kind of was a fun little, why does this not work? Oh. The next thing was to actually remove Ruby itself and use install or attempt to use make install to actually install the binaries that GitLab shell is going to be using, as opposed to checking out the Git, building everything where it is, and then copying the results in, because now we have the source in there, which isn't that much, but it's impactful. And, well, maybe we don't need all of those artifacts floating around. We definitely don't need any kind of Go package cache. Right? And the last thing is paying attention to chown, chmon, change group, and the impact those things actually have. The first thing we end up actually caring about, if we go into the Docker file, we're changing the base image over to GitLab base. So while it used to be built upon Ruby, I go to the last from here, we had from image, which actually this one was GitLab Go, which has GitLab Ruby in it. Don't ask. So moving away from Ruby, we go down to GitLab base. That's really the largest change, is that the final image actually is based on that. In doing that, doesn't seem like it makes a lot of difference, except for the fact that Ruby's not there. It can't be that big of a difference, right? Well, as I mentioned earlier, if I look at the main version of this container, I feel like I pulled the wrong main UBI8. Oh, right, I'm reading it there. Sorry. If I look at the image size on main UBI8, so the UBI8 version of the version of GitLab shell for the master branch, it's 602 megs. Okay. If we look at the image layers, the base layer, 216 megs. This is our underlying container that's got everything else in it. Who it's from. This used to be the GitLab Go image. So if we look down through where the copies come from, we have 3 adds and 2 copies, right? So the copies are the local items, from the Docker file context. So this is our scripts, these are our etc. SSH configs, things like this. The adds in UBI final images are actually adding the tarballs that come out of the build behaviors, right? So if we look at that against the actual, here's my correct tab, the order of the adds in the final image. Right here, we have shell, logger, gauntlet in that order. So we really care about these last twos right here. If I look at the one from master, we have shell, logger, gauntlet. So the order of those hasn't changed. Let's look at the GitLab shell layer, right? If we look at main, the first one here, the 100 megs that's added in. If I look at that same layer, or what would be that same layer, we have a total of 141 megs added in because we have done something interesting. If I go back to the other window, here's my tabs, sorry. Inside of the build container, we've done a few things. We now have changed up how we're actually doing the install. We changed the location and we reset everything up, and we're using install to only install the binaries that we care about. If make install had actually worked, I would have used that and it would have been simpler. Turns out there's a bug there. By setting the permissions when I do that install and placing it under the prefix, I'm only copying in the binaries because no other part of that content actually needs to be installed and consumed by the assets. We don't need any other sources, config files, doc templates, anything. We need the binaries, we need the license. That's all we're required to distribute. Okay? So we reduced this size significantly. If I pop into pipelines and I look at the size of that tarball, here's a UBI pipeline, and I'm roughly this job. Shell. The GitLab shell tarball is now 44 megs. Right there. Now if I do go look at the CNG, go to the pipelines for that, and pull up last night's master, not much of a change, right? You know, less than 1 meg change in terms of the total artifact here. We're talking about 44 versus 44.8. Doesn't make a huge amount of difference, but it does matter that we're not shipping anything we don't need. Just, it's a straightforward thing from a Linux packaging perspective. If you do not need it, don't stick it in the tarball. If you don't need it for runtime, why are you putting it on everybody's system? Right? So that's one of the first things we did there. Now, inside of the Docker file itself for UBI, what we ended up doing was inserting a build stage. So we actually do all the copying and any choning patterns prior to installing into the final image. So in this particular case, I ended up calling it staging. Probably should be named build. We can settle on a particular verbiage here at any point. Otherwise, what you'll end up seeing is, from base image as staging, and we've otherwise just inserted a bunch of things between where the from is and where the final from is. Okay. And what we essentially did is take everything that has to do with setting up the final location and the ownership and everything else, into that staging location so that we just have a final copy from that into the image. So that's why the image that I have here has a single copy in. Is because the final is copying all of its final artifacts into this container and has one layer instead of having 5 layers. Right? So I'm reducing the total number of layers, and that layer ends up actually being smaller as a result. Because if I look at the add, copy, we still end up with just a little over 144 megs. We're not talking about huge difference in size when it comes to the total content in that tarball for this image, but we are talking about great simplification as a result. We go from having 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 layers, having 6. We cut the layers in count of the final image in half. So all I really end up doing is take all of the adds and the copies, move them into the staging and or build layer, and then all of the configuration of the final files and locations and placing them up into there. In particular, the ones we care about are anything that's a chmod or absolutely anything that's recursive. Okay? This one is beyond important, and this is why this matters. If you chown or change group or chmod as a part of an OCI container, you're altering every single file under it. Okay? That means that that layer, if you're familiar with copy on write file systems, you have every file that was there and then every file that was there again. So although the final runtime container is only looks like it's got those files, the machine operating that container actually has more than one copy of those files. And worse off, has to download and extract it just to never use it. So by moving those anything recursive items up and out of the way and getting that done, when we do the final copy from staging into the final image, the only thing we end up doing chown or chmod is actually on the home directory. So these files are tiny and we're adding it in this image, so not really a problem. Or I should say adding it in this layer of this image. So it's not really a problem. We greatly simplify the final container's content. We remove the things that are generating large layers from the final images process. So does everybody follow what I've done here and the reasoning for it?
Just a quick follow-up, Jason. You still using like in the stage, in the build stage, you're still using those long one-liners with a run, which practically you could avoid and take a little bit more advantage of caching while building this stuff locally when you're testing.
Yes, you're right. I was not going for absolute optimization. I was going for make the smallest incremental change I can make and then refactor as necessary. So this is an iterative step, right? First off, get the big chunk layers out of the way. Second, we can come back round and we have other issues that are related. So if you look at the list of related work issues in the demo notes, there's first off the replacing the base image for non-Ruby runtime, and second, reduce complexity, then the use of multi-stage Docker file patterns. So I have implemented part of that reduction of complexity, but in that same issue, talking about extending the use of multi-stage, we start talking about using caching and buildx and how many runs you should and shouldn't have and things like this. I only split it in multi-stage so the end result is smaller. I did not go into the optimizing the build stages for caching patterns.
Yeah, understood. I was just pointing out the obvious, that's all.
No, that's good because it's not obvious to everyone. So what I want to point out here is how Docker layer caching and busting works. Okay. The way the layer cache works in Docker, effectively, if you rerun the same Docker build over and over again, how do you know that this layer is no longer valid cached? Right? Versus if we look at another image, some of our build images have 3 runs, and it's download, build, and I don't remember the third one. I think it might just be install. But effectively, we have 3 stages, and they all go run script, run script, run script. Right? However, those images actually should be refactored to fix up a few things. Why? The answer is those images have nothing that would tell Docker that that cache layer was ever invalidated. There's no way for it to know, because the argument is literally run scripts dependency, run scripts download, run scripts build, right? There's no parameters to those, there's no environmental arguments. Those may actually have them internally, but they're not in the run line. So if that value ever changes, Docker doesn't know that that's an indication. So if you change, say, the version as an argument, that arg changing will actually invalidate layers that are consuming that value. If you have the arg and that changes, that doesn't necessarily invalidate things that don't care about that all the time. It gets a little funny. But I don't want to go too deep into what triggers layer caching, because it's kind of a complex subject on its own. It probably could use a half-hour demo just to itself.
May I pop in with a quick question about that?
Sure.
So we're talking about layer caching and knowing something changed. But one of the challenges is, for the local developer, when we get that figured out, that works great. But in the pipelines, there's no guarantee it's in the same runner or has that cache available. So that really doesn't work for CI. So what do you think is what's your personal game plan right now for that? Because you're talking about layer caching, but in CI, it doesn't work unless we cache each intermediate stage in the multi-stage build. So
right now we don't have a plan. I don't have a plan because we don't have a plan. Okay. There are a number of things that we can look into, but we don't have any one particular thing that is like, oh, awesome. There are there are a few means to accomplish. One, we could be pushing intermediate layers. That's problematic because what are we going to do with those assets? How often are they used? How often are they cleaned up? Right? It might improve the pipeline performance, but now we have a maintenance overhead that we need to be careful of, because that is a significant OpEx, right? Operational expenditure. The other way we could look at this is actually having dedicated runners that will then have a either shared or common, might be better phrased, Docker layer cache, which includes the image cache. Okay. I don't know that makes any better sense either, because then we're putting the OpEx out on the machines, and we have a dedicated set to manage. We're resulting in pets when we want the runners to be cattle. So we have to have a good, strong reason to do that. There may be some interesting things that we can do in looking into that one, but I don't believe right now that the Docker machine driver has the ability to actually generate the machines that have a shared file system cache. And there is some concern about how do you do a shared file system with multiple container engines operating on the same file system cache. It's a little weird because they don't necessarily know that they're sharing the file system with somebody else. Right? So if one of them removes an image, the other one might be, hey, I was using that. And then be like, wait, what happened? Now, one thing that is related, but kind of off topic, but not, when we spoke about using the I typoed, it said multi-stable instead of multi-stage. When we use the multi-stage Docker, we were discussing build tools, right? Whether we use Docker or start investigating Builda or Build X or Build Kit or all of these many things. Right now, we don't have any intent to change the tooling that we're using in any way, shape, or form. It's not that we don't want to investigate those things. It's not that they won't have a return on value. It's a impact now versus idyllic conditions after, right? We do want to have an idea of where to go if there's a good reason to go, but what are the impacts of doing those things? What do those require us to otherwise do that result in those impacts? Like using BuildX with multi-layer caching with intermediate stages, those impacts are, where are those intermediate stages going to be stored? How are we going to properly identify and invalidate those? And ensure that they're properly identified and invalidated. What's that tooling require? Are we now binding ourselves to using Docker in Docker for a long period of time? How we get to the point where we're not using Docker in Docker, right? A lot of complexities start to add up super fast when we start changing things out. We may want to be to the point where we're not using Docker in Docker. I won't argue with that. But what are our options to do this without Docker and Docker, right? Here's the tools that can do that. Here's the tools that can't do that. What are the impacts on how our containers are kept, pushed, and cached? All of these things need to be evaluated. To swing this kind of back to the original question that we tangented off of, the layer caching and optimizations for a developer or versus the CI are significantly different, right? Just by the sheer fact of one job is going to run on a different machine than the last job. And the same job, even in the same pipeline, if it's reran, is going to end up on a different runner, more than likely, right? How we share that cache is a big fat question. But right now, I would like to focus on the developer experience. As much as I would love to improve CI performance and enhance that, developer experience has been historically problematic. And I would like to focus on that so that we can get more people capable and regularly willing to contribute to the project.
Yep. And that pretty much covers the ground that I was kind of on. And so I just wanted to bring that up because we know this question comes up a lot about the caches and layers and speed and that all the difficulties you just outlined in CI are fairly well known from some other experiments we've done within the team. I just, getting that on a recording so that's out there and clear, because that's, I think, the most misunderstood thing is that difference between this is faster locally and in CI, I don't care. Like those environments are so different, we can't have an analog. It's mutually exclusive optimization almost. So that is just the thing I wanted to make sure we cleared up and called out early. So thank you for going over that. Appreciate it.
Yep. Okay. I'm going to look real quick at Workhorse as well. So if I this and I pull up another one, go over to the workhorse MR that I have up. The real changes that I have in place here are not changing Ruby out. Okay, I haven't done anything on this one other than chown, just to show the difference in size impact. Okay. The final image sizes. If we look at the current master for UBI8, the size stored in the registry, so the compressed tarballs in total is 680 megs. When it's uncompressed on the disks, all layers included, it's 1.6 gigs. That seems a lot for a binary that's Go and a config template engine and what works out to be around 300 megs of actual public assets that it's supposed to serve out from static files. 1.6 gigs, folks. We can make a ding in that by just fixing up multi-layer, right? As I said, build versus staging, whatever you want to call that particular layer. This time I called it build. Don't ask me why I did anything different. Just by moving those chones and CH groups, we save 240 megs in the compressor alone. We save half a gig just on all of the things that we actually did chones and CH groups on. And it really is as small as taking the chunk, moving it into an intermediate layer, and then doing all of the recursion on those underlying directories. Then copying that result from the build stage or the staging stage into the final stage. Just doing that saves half a gig on disk for the operator. That includes us, right? Now, it seems kind of silly that this little tiny thing would have such an impact, but one of the biggest things that's in there are the actual assets. Okay, so we have all of the workhorse targz. Inside of workhorse's targz, you actually have the workhorse and its binaries, any of its supplementary config example files, and the entire public assets directory, which, by the way, has another thing wrong with it. But that means basically all of the contents of serve GitLab in the workhorse container. Because the contents of just the public assets container are 383 megs. Okay. Not having to touch the permissions on those means we don't have 2 copies of 383 megs. That's expensive. And it doesn't seem like it has that much of an impact in the final image size, right? We're talking about, oh, gee, it's, 200 megs, but we have 300 compressed. That's not bad. Well, that's 240 megs that we don't have to transfer over the wire, that we're not paying, that the customer isn't paying, that the machine doesn't have to spend time transferring over the network. So transit time alone, storage costs for us, ingress costs for them. Okay? At a half a gig, uncompressed, that's 1/2 gig of data that they don't have to decompress onto their disk, and they don't have to spend the time in CPU cycles or IO time, which means that the container will start that much faster, no matter who runs it, because it's 1/4 of a gig less to transfer, half a gig less to uncompress. That's going to be completely unused. We get another little bit of a gain when we get off of the Ruby image, but just fixing the chown alone through the multi-stage patterns fixes a significant impact. And many of our images have this problem, by the way. But this is a small change that just refactors how we're putting the contents in. that has a massive impact on actual usability and startup times from deploy this chart. Okay, now every node that needs to run Workhorse needs to pull how many layers down that are how big, how long does it take? Like, anybody who's worked in the charts and tried to start this thing up, the amount of time it takes to start the container versus the amount of time it takes to prepare the container to be started, right? Customers don't measure it from the time the container is ready to the time the container is started. They measure it from the time I said deploy it and it's actually running. The viewpoint is different than that of a developer. Okay? This tiny optimization in terms of number of changes results in significant impact for everybody who would use it. Let's not even get like into the weeds of details of how much this saves us in ingress egress, in cost, and layer caching and everything else. Any other questions, comments, inputs, please?
I know that you recently added a MR widget that shows the size changes in images for MRs. I'm just thinking, would it ever be worth it to have a little job in the CI that's maybe allowed to fail or not allowed to fail that would basically alarm us if an image got too big, just so we never get back into a point where we add something that we think is innocent and it ends up making a huge additional change in the storage of an image? Mostly asked just because it could be easy to be looking at the details of the change set and maybe forget to expand that MR widget or forget to look at that specific line for how that image changed.
So first thing I'll say is, yes, that's in place. It does work. I will also say, while I say it works, not the best. It's got some hiccups. It's designed in the right fashion, but the result is a little problematic. I put it together so we did generate metrics, and you can actually pull those metrics files and do a direct comparison of the branch you're trying to merge to versus ours. However, the widget doesn't actually work that way. So, oops. To that point, like if you look at the widget from MR to MR, and I could show you in a second if you want. It'll say like, yeah, there's 44 changed. There's like, no, there wasn't. And that's a matter of misunderstanding how that actually works and or needing to get QE to help me out to better understand how to present the data to make it happy. Because of that, I think it may make sense to have a job that basically says these are kind of what our expected values are. But how do we record what the expected values are or allowable sizes are? Do we end up checking that in a Git? Where do we check it in at? I don't know. Like, it totally makes sense. Like, we have a job in the omnibus that actually goes, hey, the package is too big. We should have those for the containers. Like, hey, we added such and such component. Well, now you've added Perl to an image that didn't have it before. Hey, kiss 150 megs goodbye. Yeah, it totally makes sense.
Kind of along the same lines, I know that there is a MR in works right now that expands the API for the GitLab. So you can actually, when you query for the tags, you can get the sizes of each tag for the container registry as well along with it. So you don't have to do the queries, the longer queries to expand each tag. And so we can actually plot it out much easier, like the general view, and kind of see strategically what was happening over time with a thing. It doesn't address the concern that Jason's widget is addressing, and that's immediate view of like, is my change impacting negatively, the commit? But at least it gives us as a team a view of, okay, over time, we just assumed another 100 gig for like 100 meg for no good reason, or whatever that case may be.
Nice. And this is, I didn't actually end up using Scopio in a demonstration at this point. One thing that we have is we have a certain amount of information available to us because we're building the containers and they're local. We can just do Docker inspect and pull some information out of that JSON. Scopio operates primarily, you can actually tell it just to talk directly to the registry over the API. That's really what actually ends up building out the metrics. So the image metrics job right now, actually, sorry, cat bumping my mic all the time. The image metrics job runs Scopio over all the recorded final images and looks for what changed. It just records those images, and here's the image name, and here's the tag name, and then pull the information from the registry. And it does this effectively by just making the query on the specific tag and then pulling the information back that we care about. How many layers do I have? Scopio inspect -- raw will give you completely different input, or output, I should say, than Scopio inspect. Because the raw will actually go pull the manifest information directly back, and then you can interact with that data. So you can, if you do Docker inspect on an image and you look at the layers, it'll list what the layers are by JA, right? And roughly what those sizes are. But if you do .size, it will just tell you how big the image is. Whereas when you look at it inside of Scopio, it will actually tell you the tarball size individually for every single layer, so you can add those up. And if your tarballs add up to a certain size, and then your extracted size doesn't line up, some of that's compression, some of that's how much of this is overwritten by multiple layers.
Yeah, maybe some of that could be plugged into Danger too, if that sounds feasible. Seems like maybe the right mental place to put it for that kind of feedback.
Well, maybe. Up hitting the mic. The trick there is we don't know that until we're done. And we traditionally want Danger to run beforehand.
True.
So we would actually kind of have two Danger jobs
Hmm.
that do different things. We have one at the beginning of the pipeline and one at the end of the pipeline, right?
I just liked that it gave a comment, so then it can be a discussion, it can be resolved. That's a nice aspect of it. But yeah, I see what you mean. Because I was kind of thinking maybe we just go off percentages. Danger could leave a note that this image got 10% bigger. That way we don't have to have hard coded storage acceptable sizes, but at least we gotta get a sense like, hey, this got 10% bigger, or this got 80% bigger, and we can catch that.
Right. And yeah, if any image ever gets 80% bigger, we did something wrong.
Yeah.
Wow. You good? Okay. It's lap time, apparently. And I don't mean sitting on mine. I mean doing laps on mine. Yeah.
Both.
Yeah. So, yeah, if we could figure out a sane way to somehow run multiple Danger jobs without Danger overriding its own prior comment, maybe? We could definitely, either way, improve the total experience of those metrics and how we manage them. Yeah.
Yeah, I think ideally it would be that widget operating as we expect, because that's where other helpful data is too. So maybe we can give feedback back upstream.
Right. Right. Well, we're coming up at the end of the hour. Does anybody else have questions or input? Okay. So what I do want to talk about just before we leave is future work as a relation to this one. One, yeah, we need to document these optimization patterns and those practices into the CNG's guidelines so that future worker or contributors understand and have a guideline to work off of. And we need to spend the time to analyze every image and outline the work that needs to be done to try to optimize each image individually. Much of them, we can fix them by just fixing up chones. Those are relatively small changes, as I've demonstrated with the workhorse. But there's a few of them where we need to actually consider, are our artifacts too big in the first place? Right? There's been a few instances of that over the period of time. I mean, we had a prior issue where we inadvertently packaged the Go cache with the GitLab artifact. So the final image had the extra gigabyte of junk in there. Like, oh, whoops, fix that. But there are some continual things that can be further optimized even on top of this, right? So GitLab base was put in place so that we have that foundational, we could start taking Ruby out. But as of yet, every final image gets complet added to it. Every final image gets GitLab logger added to it if it doesn't have JSON logging, right? So we could centralize some of these other things. We haven't spent the time to go through every image and find out exactly which processes or packages should be installed on GitLab base so that they don't need to be added as an additional layer for everything else. Like, Goblet could be safely put into every image. It's not in every image right now. It saves 20 megs, which doesn't seem like much, right? But if that's 20 megs in a layer in all of the UBI images with an additional layer. An additional different layer at that, right? Whereas if you have one single consolidated layer, that actually ends up being less storage for less objects in the object cache or object storage that we use to back the registry. One less thing that the user has to download, right? Those kinds of things are further optimizations that we can do down the road. And we need to spend the time on to be able to improve this for everybody. All right. Well, thanks everybody for coming. Hope you learned something. Everybody who's watching in the background. That was dense. Don't worry, watch it twice.